Hey guys, hi, welcome back. So in the last video, what we discussed was the definition, types, and the methods of charging. And in this video, what we will discuss is the properties of charges. Okay, we will just see the basic properties of charges. There are 5 to 8 properties. Okay, so the first property of charge is what, according to Benjamin Franklin, he said that there are two types of charges. One is the positive charge and the other one is a negative charge. Okay. So this is the very first property which we have already seen in the last video also, that we have two types of charges. So this is one of the property. Second is what, that if you're having like charges means similar charges. Okay. You can say like charges to be similar charges and unlike charges to be what? Dissimilar charges. Okay. You can say it to be dissimilar. So like charges will always repel and unlike charges will always attract. That means if you're having two positive charge or two negative charge, then they will always what, repel each other. That means they will go away from each other. But if you're having a positive charge and a negative charge, or a negative charge and a positive charge, they will always attract. That means they will always come towards each other. So this is the second property of charges. The second property is clear. Now we will see the third property of charges. So what the third property of charge is, it is always associated with mass. That means charge cannot exist without mass. Okay, it needs mass to exist. Okay, the fourth is what, charge is a conserved quantity. That means charge can neither be created nor it can be destroyed. So if you have an isolated system, the charge will always remain constant. Suppose if I'm considering here to be a isolated system. So if I say here you're having -1 coulomb charge, here I am having 3 coulomb charge. Again, I'm having here how much? 2 coulomb charge. So if I see here, the total charge is how much? 4 coulomb. Just taking the algebraic sum. This is also charge is additive. That is also a property we will see later on. So here it is how much? Total charge is 4 coulomb. So somehow if you have just thrown this isolated systems into some other condition, in that particular case, what will be the charge? It will remain constant. Charge won't change. Okay, the total charge won't change. So in that case, what will happen is that the total charge, this is how much? 6 coulomb, suppose. Okay, here you are having how much? -3 coulomb. Okay, and here you are having what? 1 coulomb. Okay, so here also if you see, the total charge is what? 6 plus 1 minus 3, that is 1 I system will have constant charge. You cannot create, neither you can destroy. Clear? The next property is what? Charge is quantized. Okay, charge is a quantized quantity. That means the total charge on any body, it is equals to what? Integral multiple of the fundamental charge E. That means if you are having any body, we know the charge is denoted by Q. So Q is equals to what? It is equals to integral multiple of the fundamental charge E, and integral multiple is N. Means charge on any body will be what? Q is equals to NE. Here N is the integral multiple and E is what? E is the fundamental charge. Okay, that means you can write Q is equals to NE. This is the formula of charge. Okay, here N is equals to what? It is an integer. Okay, it is an integer, and you can write it to be 1, 2, 3, and so on. Okay, and one thing you will have to remember here is that charge can be what? 1e, it can be 2e, it cannot be 3.5e, because 3.5 means it is in a fraction, so it is not an integer, right? So it can be 1e, 2e, 3e. That is, it is a fixed quantity. It cannot, because you can say that, you cannot say someone that you need 1.5 charge. Okay, charge is a quantized quantity. You cannot say you need 1.5, because either one electron will be donated. Okay, means if you're having two bodies, then it can take either one electron or two electron. It cannot take 1.5 electron or 3.5 or 4.5. Okay, in fraction it cannot take. It can take whole. Okay, so this is one important property, that charge is a quantized quantity. Okay, and the minimum positive possible charge is how much? You can just see the minimum possible charge. Sometimes you might be asked, what is the minimum possible charge? So the minimal possible charge, it is equals to a plus minus 1.6 into 10 to the power minus 19 coulomb. Here always there will be a plus and minus, because if the charge is positive, that means what? It has donated electrons. Okay, and if it is minus, okay, charge is negative, that means it has gained electrons. So this is what the positive and the negative sign shows. And the minimal possible charge will be how much? It is plus minus 1.6 into 10 to the power minus 19 coulomb. If it's positive, that means it has given that much of charge, right? And if it's negative, it has taken. Okay. So minimum, because we know charge is what? Integral multiple of the fundamental charge is. So any body must has the minimum charge that tough. You understood? Charge is invariant. Okay. Charge is invariant. That means what? Charge is independent. It is independent of what? The frame of reference. That is, charge on a body does not change. Charge on a body is not changing it with what? With its speed. Okay. Whatever might be its speed, it will not change. Remember, this is a very, very important property which we will see in the difference also between charge and mass. Because if you study the relativistic mass and all those things, now you will understand it well that mass increases with speed, but charge does not. Okay. Suppose if you have seen m is equals to, you have seen this equation, I think m is equals to m naught by root over 1 minus v square by c square. Okay. So charge is invariant. It means it is fixed. Okay. Fix that value of charge. Okay. If you're having a particle which is having some particular value of charge, then it won't change. Okay. If you take an electron, for example, so it will, if it is a okay, though its relative mass will not increase. Okay, even if the particle will move with very, very high speed. Okay, in that case also what will happen? Charge will not change. Mass can change. Okay, but charge will not. Mass will increase. When we know that when a particle is moving with very high speed, its mass is what? Increasing. Okay, but charge is not increasing. Remember, and this can be shown with this equation, which we will later on we will see when we will see the difference between charge and mass. Okay, the last and very important property of charge is what? Charge is additive. Okay, what is the property of charge is what? It is additive. That is, total charge of an isolated system is equal to the algebraic sum of charges of individual bodies of the system. So how you will understand this, that if you're having a system, okay, suppose, okay, consider a system. Okay, consider system of three charges. System of how many charges? I'm considering a system of three charges. Okay, what this statement means, that we will see. If you're having a system of three charges, that is q1, q2 and q3. Okay, then total charge will be what on this system? Then total charge on the system, then total charge on the system is what? Capital Q is equals to what? Q1 plus Q2 plus Q3. This is the additive nature. If I say you Q1 is equals to what? 2 coulomb. If I say Q2 is equals to minus 3 coulomb and Q3 is equals to plus 5 coulomb. Okay, this is also positive. And then what will be the total charge? How you write? Q is equals to what? Plus 2 coulomb. Okay, minus 3 coulomb. Again, plus 5 coulomb. Okay, plus a minus a is what? Minus 3 minus 2 is what? 1 coulomb. The greater number is what? Minus, so you write minus, plus 5 coulomb. And from here again, 5 minus 1 is what? 4 coulomb. Basic algebra we have done. And this is plus 4 coulomb. So the system will have plus 4 coulomb charge. So this is said to be the additive property of charge, that you will always take the total charge of an isolated system as the algebraic sum of what? Individual charge on the bodies, okay, of a system. So I think this is very clear. These are the properties of charges, which are very easy. I don't think it's that tough. Just remember, you're having two types of charges: positive charge, negative charge. Like charges will attract and unlike charges will repel. Charge is conserved, charge is quantized, charge is invariant, charge is additive. Okay, and you already know, I guess, that when we're discussing that when a body, this is also a property, you can just highlight it. We have already seen this in the last video. So when a body is what, you can just add here, this is also a property. Okay, when a body is what? When a body is positively charged. Okay, when a body is positively charged, what will happen? It will always what? Lose electrons. Positive charged body will lose electrons, and its mass will what? Mass will decrease. Okay. And when a body is negatively charged, so the reverse will happen. When a body is negatively charged, what will happen? It will always gain electrons. It will gain electrons. Since it's gaining electrons, its mass will also what? Increase. Mass increases. Okay. So this is also a property you can take. Clear? So I think the property of charge is clear. In the next video, we will see the difference between mass and charge. That's all in this video. Thank you so much. Have a good day.